Today's customers have an increased awareness and commitment to quality and service. This places new demands on dealership technicians who are trying to achieve a high level of customer satisfaction. To assist the technicians in meeting this demand for service excellence, the Ford Parts and Service Division has introduced the Service Technician Specialty Training (STST) program. While developing this improved approach to service training, the technical training staff consulted with the training subcommittee of the National Service Managers Advisory Committee, as well as the District Service Engineers Advisory Committee. The result is a training program that will make available to Ford and Lincoln Mercury technicians the information and skills necessary to fix it right the first time. A full menu of new courses are being developed to fully train technicians in these specialty areas: engine performance, engine repair, suspension and steering, electrical systems, climate control, manual transmission and drivetrain, automatic transmission and drivetrain, brakes, and pre-delivery. Training schedules provided by your district office will announce when courses relating to these specialties will be offered.
The new generation of the Ford automatic overdrive transmission is the AODE. The AODE transmission first appears in the 1992 Lincoln Town Car and will also appear in the Ford Crown Victoria and Mercury Grand Marquis later in the 92 model year. Major component changes on the AODE include the torque converter, which now features a pressure plate style clutch for mechanical transfer of power in second, third, and fourth gears. The fluid pump, which is now a gear rotor design instead of the AOD gear and crescent design, and the main control body, which now features electronic solenoids and a revised valve setup. Several minor component changes have also been made, including changes to the input shaft, clutch assemblies, and output shaft. A stub shaft has also been added to couple the input shaft to the direct clutch. Like its predecessor, the AODE still features a Ravigno gear set, which produces 4 forward speeds plus reverse. The largest area of change on the AODE is in the control system. The EEC4 processor and a network of sensors, switches, and electronic solenoids has replaced the purely mechanical and hydraulic controls. Driver demands can now be translated electronically to the AODE control system through the shift lever, accelerator pedal, and brake pedal, while engine load and transmission conditions are provided to the control system through a network of sensors and switches. The control center for this system is the EEC4 processor. The processor takes the input information from the sensor network and uses that information to control the solenoids in the AODE control body. These solenoids in turn affect the shift timing, shift feel, and converter clutch operation for the AODE transmission. Now, throughout this presentation, we'll occasionally be asking you to stop the tape and answer some questions in the back of your reference book to help you review the material just covered. When you restart the tape, we'll give you the correct answers along with a brief explanation. So let's try a few. Please stop the tape here and answer review questions 1 through 4 in your reference book. We'll have the answers for you when you restart the tape. Review question 1 asks you which areas of the AODE transmission feature a change from the AOD. There are 3 correct answers: A, B, and D. The fluid pump, main control body, and control system have all been changed. The planetary gear set, answer C, remains the same. The answer to review question 2 is A. Mechanical transfer of power from the engine to the transmission in second, third, and fourth gears is provided by an electronically controlled converter clutch on the AODE. This clutch replaces the split torque system used on the AOD. For review question 3, answers A, B, and C are correct. So the correct answer is D, all of the above. Driver demands are translated to the AODE control system through the shift selector lever, the accelerator pedal, and the brake pedal. And the correct answer to review question 4 is also D. The EEC4 processor makes decisions on shift timing, shift feel, and converter clutch operation for the AODE. Now, your reference book provides complete information on those areas of the AODE transmission which are similar to the AOD. Because there are no major changes in these areas, we won't be covering them in this video. However, we encourage you to read the major mechanical components, mechanical power flow, and hydraulic component sections of the reference book. Review questions 5 through 12 are dedicated to these sections. You may answer these review questions on your own and check your answers with those in the back of the book. Now let's take a look at the new control system for the AODE. All major functions of the transmission are now controlled by electronics. The EEC4 processor determines engine load, driver demands, transmission state, and other vehicle conditions through a network of sensors and switches. After processing the information from these inputs, the EEC4 controls the solenoids which affect shifting, line pressure, and torque converter clutch operation. Let's now take a closer look at the AODE transmission control inputs to the EEC4 processor. There are 6 inputs related to engine load or driver demands. First, there is the throttle position or TP sensor. You may be familiar with this sensor since it is part of other electronic transmission control systems. The TP sensor uses a potentiometer to detect the throttle plate opening, which is related to accelerator pedal position. The sensor then sends a related voltage signal to the EEC4 processor. The information from the TP sensor is used for the following AODE functions: shift scheduling, modulated converter clutch control, and EPC solenoid pressure control. Engine-related sensors for the AODE include the mass airflow or MAF sensor, mounted on the air cleaner duct. The MAF sensor measures the rate of airflow into the engine. The air charge temperature, or ACT sensor, mounted on the air cleaner, provides information on the temperature of the air entering the engine. The EEC4 processor uses both the MAF and ACT sensor information as part of its engine load calculation. This information affects shift scheduling, converter clutch control, and EPC solenoid pressure. Another input used in the engine load calculation is the profile ignition pickup, or PIP signal. The electronic distributorless ignition system, or EDIS module, receives a cylinder identification signal from the crankshaft sensor, then translates this into a PIP signal. Specifically, this signal relates the engine RPM to the EEC4 processor. The RPM information translated from the CID signal is mainly used in shift and converter clutch scheduling. The engine coolant temperature, or ECT sensor, is another engine-related input to the AODE control system. The ECT sensor uses a thermistor to tell the EEC4 processor the temperature of the engine coolant. This information affects converter clutch control operation. If the engine is too cold, the EEC4 processor will prevent converter clutch application, thus helping prevent engine stall. However, the ECT sensor information is a secondary temperature input to the EEC4 processor. The processor will use the ECT information only when it cannot read an input from the transmission oil temperature sensor, which we'll look at in a moment. The air conditioning compressor clutch also provides an input to the EEC4 processor. When the AC clutch is on, the processor will command a boost in EPC solenoid pressure to compensate for the additional engine load. An input to the AODE control system that is controlled by the driver is the brake on-off or BOO switch. The normally open brake on-off switch is mounted on the brake pedal bracket and closes to tell the EEC4 processor when the brakes are applied. This information is used to disengage the converter clutch when the brakes are applied. Now let's look at the AODE inputs mounted on the transmission, which are all related to transmission operation. The first of these inputs is the manual lever position sensor, or MLPS. The MLPS is controlled by the manual lever when the driver selects a range on the gear shift lever. It uses a step-down resistor network to tell the EEC4 processor the manual lever position of the transmission. This information is used to determine the desired gear range and EPC solenoid pressure. The MLPS also contains the park neutral start switch and the backup lamp circuit. Another transmission-mounted input is the output shaft speed, or OSS sensor. The OSS sensor performs a function similar to the governor on the old AOD, only it does it electronically. Specifically, it tells the EEC4 processor the output speed of the transmission by sensing the rotation of the output shaft ring gear. This transmission speed information is necessary for shift scheduling, converter clutch control, and EPC solenoid pressure regulation in the AODE transmission. Further toward the rear of the AODE is the vehicle speed sensor, or VSS. The signal from the VSS is used as an additional speed input to the EEC4 and may cause upshift schedules to be modified. However, the OSS is the primary transmission speed input. There is one more transmission-mounted input, and that is the transmission oil temperature, or TOT sensor. This sensor is mounted on the main control body in the transmission. Like the ECT sensor, the TOT sensor uses a thermistor, this time to tell the EEC4 processor the temperature of the fluid in the transmission pan. The processor uses this information to determine if a cold start shift schedule is necessary. The processor will also use TOT sensor information to keep the converter clutch disengaged if the transmission temperature is too low. Those are all of the AODE inputs. Before we move on, let's show you one more important component on the AODE transmission, the transmission electrical connector. The transmission connector contains the pins for all of the internal transmission circuits. These include the TOT sensor and all 4 solenoids. We'll look at the transmission connector more in our discussion on diagnostics. Now let's review the AODE control system inputs we've just looked at. The inputs related to vehicle condition external to the transmission include the throttle position, or TP sensor, the mass airflow, or MAF sensor, the air charge temperature, or ACT sensor, the PIP signal from the EDIS module, the engine coolant temperature, or ECT sensor, the air conditioning clutch, and the brake on-off, or BOO switch. These inputs generally provide information related to engine load or driver demands to the EEC4 processor. The transmission-mounted inputs to the EEC4 processor include the manual lever position sensor, or MLPS, the output shaft speed, or OSS sensor, the transmission oil temperature, or TOT sensor, and the vehicle speed sensor, or VSS, which provides a secondary speed input to the EEC4 processor. Now it's time for some more review questions. Please stop the tape here and answer review questions 13, 14, and 15 in the back of your reference book. We'll have the answers for you when you restart the tape. Now, here are the answers to review questions 13, 14, and 15. Question 13 asked you to identify selected AODE inputs as providing either engine or transmission-related information. The correct answers are as follows. The manual lever position sensor is a transmission-related input. The engine coolant temperature sensor is engine-related. The mass airflow sensor is engine-related. The output shaft speed sensor is transmission-related. The EDIS signal is engine-related. And the air charge temperature sensor is also engine-related. The answer to review question 14 is A. The driver's demand for torque is transmitted to the AODE control system through the use of a throttle position, or TP sensor. The answer to review question 15 is C. The primary speed input used in AODE transmission control is the output shaft speed, or OSS sensor. The vehicle speed sensor is a secondary speed input, and its information is only used to modify upshift schedules. Now let's move on to the outputs in the AODE control system. The EEC4 processor controls 4 solenoids as outputs: a modulated converter clutch control, or MCCC solenoid, 2 shift solenoids called SS1 and SS2, and an electronic pressure control, or EPC solenoid. Let's take a look at each type of solenoid in detail. The shift solenoids can only open or close a fluid passage. The modulated converter clutch control, or MCCC solenoid, can vary its output almost infinitely. The MCCC solenoid is pulse width modulated, which means it adjusts its position based on the percentage of duty cycle voltage. The EEC4 processor controls the duty cycle by varying its ground switching. At 0% duty cycle, the MCCC solenoid completely closes the ball valve, blocking the fluid output. With a higher duty cycle percentage, the MCCC solenoid will start to rapidly turn on and off. This now allows some of the fluid pressure to flow to the converter clutch control valve. As the duty cycle percentage gets even higher, the on time of the solenoid gets longer, and the solenoid allows even more pressure to flow to the valve. At 100% duty cycle, the MCCC solenoid valve simply remains fully open and full pressure flows to the converter clutch control valve. We'll explain how this affects the converter clutch itself later. Unlike the MCCC solenoid, the 2 shift solenoids used in the AODE are simple on-off types. They are mounted together in a special housing which is installed in the main control body. The shift solenoids are always serviced as a complete assembly. In the off position, an internal spring holds the shift solenoid ball valve and armature up. This allows some of the fluid pressure passing the solenoid to bleed off to the sump. Thus, the output of the solenoid is less than the input, and the shift valve fed by the solenoid won't be shifted. When the solenoid is turned on by the EEC4 processor, the armature and ball valve move outward and seal off the path to the sump. This means that full pressure will now flow to the appropriate shift valve. We'll show you how the shift solenoids operate in an overall hydraulic circuit in a moment. The electronic pressure control, or EPC solenoid, is unique in that it uses a spool valve. The EEC4 processor controls the current at the EPC solenoid, which adjusts the spool valve position. When there is no ground at the processor, there is no current flow in the circuit, and internal solenoid pressure holds the valve fully outward. This keeps EPC output pressure at its maximum. However, as the processor varies the ground to allow more current flow through the circuit, internal solenoid pressure is reduced and the valve moves back, reducing solenoid output pressure accordingly. Next, we'll show you how the AODE solenoids affect their respective hydraulic circuits. But first, it's time for a few more review questions. Please stop the tape here and answer review questions 16, 17, and 18 in the back of your reference book. We'll give you the answers in a moment. Question 16 asks how many solenoids are controlled by the EEC4 processor in the AODE control system. The correct answer is D. There are 4 solenoids: shift solenoid 1, shift solenoid 2, the modulated converter clutch control solenoid, and the electronic pressure control solenoid. The answer to review question 17 is C. At a duty cycle greater than 0 but less than 100%, the modulated converter clutch control solenoid is rapidly pulsed on and off. The greater the duty cycle, the longer the on time. The answer to review question 18 is B. When the EEC4 module allows no current in the EPC solenoid circuit, solenoid output pressure is at its highest. Now it's time to look at some examples of how the solenoids we've shown you affect the hydraulic operation of the AODE. For our first example, let's examine the operation of the shift solenoids during a 1-2 shift. In overdrive range first gear, solenoid 1 is on and solenoid 2 is off. With solenoid 1 on, full pressure flows to the 1-2 shift valve, holding it inward against spring pressure. Solenoid 2 is off, so some of the feed pressure bleeds out the exhaust port, and the 2-3 shift valve is not moved. The position of the 1-2 shift valve causes manual valve pressure to be blocked at the shift valve. However, manual valve pressure does flow to the forward clutch by way of the 3/4 shift and orifice control valves. The forward clutch is the only hydraulically applied friction element in first gear. You'll notice that solenoid 1 pressure also flows to the 3/4 shift valve, but the valve is not moved. That's because it takes the combined pressures from both shift solenoids to overcome the spring force at this valve. To initiate a shift to second gear, the EEC4 processor turns shift solenoid 1 off. Solenoid fluid pressure is now reduced at the 1-2 shift valve, and the valve moves outward. This opens up a passage for manual valve pressure to flow to the intermediate clutch. For a shift from second to third, the EEC4 processor turns solenoid 2 on and leaves solenoid 1 off. Thus, the 1-2 shift valve remains outward and fluid still flows to the intermediate clutch. However, solenoid 2 now allows full pressure to the 2-3 shift valve, moving the valve inward. This causes pressure from a second manual valve passage to flow from the 2-3 shift valve to the direct clutch by way of the 2-3 backout valve. The 2-3 shift gives us a good opportunity to show you how the electronic pressure control solenoid can affect the feel of a shift. If acceleration is light, the EEC4 processor, acting on a signal from the TP sensor, commands higher current flow in the EPC solenoid circuit. This means the pressure output of the EPC solenoid will be low, and the 2-3 backout valve will remain inward. The fluid from the 2-3 shift valve now flows through the E orifice, and engagement at the direct clutch is relatively soft. On the other hand, if acceleration is heavy, the EEC4 processor will reduce the current in the EPC solenoid circuit. As you know from our previous discussion on the EPC solenoid, this will increase the pressure output of the solenoid. The increased pressure shifts the 2-3 backout valve outward, causing the 2-3 shift valve pressure to now flow through the K orifice. The K orifice is less restricted than the E orifice, so direct clutch engagements will be firmer. The EPC solenoid and 2-3 backout valve also help control the feel of a 4-3 downshift in this same way. Now let's go back to the shift solenoids and take a look at the 3/4 shift. For a shift into fourth gear, both shift solenoids are turned on by the EEC4 processor. The combined pressures from both of these solenoids is now enough to shift the 3/4 shift valve. The new valve position now directs manual valve pressure to the outside of the overdrive servo regulator valve, keeping this valve from regulating while it also exhausts overdrive servo release pressure. This allows full pressure to the apply side of the overdrive servo, applying the overdrive band. The new position of the 3/4 shift valve also exhausts forward clutch pressure, allowing the clutch to release. We'll discuss the converter clutch control hydraulic circuit in a moment. Right now, let's review our presentation on shift solenoid and EPC solenoid functions with a few more questions. Please stop the tape here and answer review questions 19 and 20 in your reference book. As before, we'll give you the answers when you restart the tape. The answer to review question 19 is B. To initiate a 2-3 shift in the overdrive or drive range, shift solenoid 2 is turned on, allowing full fluid pressure to flow to the 2-3 shift valve. This allows manual valve oil to flow to the 2-3 backout valve and direct clutch. The answer to review question 20 is D. The EPC solenoid affects the feel of the 2-3 and 4-3 shifts by varying its output pressure to the 2-3 backout valve. This changes the orifice that the fluid must pass through. Now, let's look at the modulated converter clutch control solenoid and its effect on the converter apply and release circuits. To keep the converter clutch released, the EEC4 processor commands 0 pulse width in the MCCC solenoid circuit. This keeps the solenoid valve closed, and no pressure can flow to the converter clutch control valve. With the valve fully inward, fluid from the converter pressure limit valve flows freely to the release side of the converter clutch. Clutch apply pressure, meanwhile, must pass through an orifice on its way to the converter. If controlled slip of the converter clutch is desired by the EEC4 processor, but not full apply, The processor allows a higher percentage duty cycle in the MCCC solenoid circuit. The solenoid begins to rapidly pulse on and off, allowing some fluid pressure to flow to the converter clutch control valve. The valve moves enough to let some of the clutch apply fluid flow through an unrestricted path to the apply side of the clutch. The valve also starts to open up an exhaust passage for some of the clutch release fluid. There are varying levels of valve movement, which relate to varying amounts of converter clutch slip. If full clutch apply is needed, the AODE-E processor allows 100% duty cycle in the MCCC solenoid circuit. The solenoid now allows full pressure to the converter clutch control valve. The valve moves fully outward, and all of the clutch release fluid is exhausted. Because full pressure is still flowing to the apply side, the converter clutch is fully applied. Now let's take some time to answer another review question, this time on the converter clutch control circuit. Please stop the tape here and answer review question number 21 in your reference book. The answer will be provided when you restart the tape. For review question 21, answers A, B, and D are all correct. The MCCC solenoid can release the converter clutch by blocking the fluid passage to the converter clutch control valve. It can apply the clutch by completely opening the passage to the valve, or it can modulate the pressure to the valve for controlled slip of the converter clutch. The MCCC solenoid does not select between two passages, so answer C is incorrect. That's all we have for you on the theory and operation segment of this AODE videotape. Your reference book goes into much greater detail, especially in the areas of mechanical power flow and electrohydraulic operation. Be sure you're familiar with the material covered in the book, and also take the time to review Part 1 of this videotape if possible. Our next segment focuses on AODE diagnosis. In this segment, we'll cover the overall diagnostic procedures for the AODE and discuss specific techniques for several of the steps. The 1992 shop manual diagnostics have been printed in the reference book for your convenience. You should refer to the appropriate procedures as they're discussed. At the end of this section, we'll also take you through a sample diagnostic exercise in which the powertrain control and emissions diagnosis manual will be used in addition to the reference book procedures. Throughout this diagnostic overview, we'll also be making reference to a new transmission tester. This electronic tester is used for internal diagnosis of the transmission and for pinpoint testing. A complete overview of the tester and its uses follows this diagnosis segment. Now, let's get started with the AODE diagnostic procedures. As with all automatic transmission diagnosis, the first step is careful attention and interpretation of the customer concern. In part, you should seek to answer the following questions. Did the condition occur all at once, or did it build up over a period of time? Does the condition occur in all gear ranges or only certain ones? Did the condition occur after service? The next diagnostic step is to perform the preliminary checks. These checks include checking the fluid level and condition, checking the engine and transmission wiring for noticeably loose, damaged, or disconnected electrical connectors, and checking for possible electrical interference from non-factory add-on equipment, such as cellular phones, CB radios, or items wired into the transmission or AODE-E harness. Next, you should verify the customer's concern. Be sure to record all findings. Back in the shop, you should now look up the customer concern on the diagnostic condition cause charts in the vehicle shop manual. These charts should direct you to the diagnostic routines that must be performed. If the condition cause chart directs you to perform electrical diagnosis along with any other checks, be sure to perform the electrical diagnosis first. This may eliminate the need for you to disassemble the transmission. The first electrical routine the chart asks you to perform is the AODE-E quick test using the Superstar 2 tester. The tester hookups and quick test procedures are explained in the Powertrain Control and Emissions Diagnosis Manual. Be sure to record all codes you receive during the quick test. If there are any engine codes retrieved, have these serviced first. This may take care of the concern. The pinpoint tests for these codes are in the Powertrain Control and Emissions Diagnosis Manual. If you receive any transmission codes during quick testing, go to the 3-digit service code chart in the Powertrain Control and Emissions Diagnosis Manual and perform the related pinpoint test for the code you received. The Powertrain Control Manual contains the pinpoint tests for diagnosing concerns external to the transmission, while the Vehicle Shop Manual contains pinpoint tests for internal transmission concerns. The pinpoint tests in the Vehicle Shop Manual are somewhat different than those for previous electronically controlled transmissions. This is because the new transmission tester, number 007-00085, is used for many of the checks involved. If you are directed to perform electrical diagnosis, your next step is to run a check of the electrical circuits inside the transmission using the new transmission tester. This will verify if an electrical problem exists in the transmission itself. The instructions for running the transmission bench checks on the transmission tester can be found in the tester instruction booklet, which is included in the tester kit. These checks include such items as a solenoid functional check, solenoid resistance checks, and checks of the TOT and OSS sensors. Perform only those tests related to your particular condition. If the transmission tester reveals no electrical problems in the bench tests, there still may be a problem within the transmission. In this case, you will also perform the engine running or road tests using the tester. There are several tests you can perform both in the service bay and on the road, including EPC solenoid checks, engagement checks, even upshift, downshift, and converter clutch engagement checks where you control the actions using the tester rotary switch and solenoid activation switches. If you found no problems on either the bench or road test, but a problem existed on your earlier road checks, it's likely that the problem is not in the transmission. In this case, you may want to check the engine-related inputs, the processor, and the vehicle wiring. Of course, if the problem did show up on the road, but you can't verify any solenoid or electrical problems, you should go back to the Vehicle Shop Manual Conditions Cause Charts and perform the hydraulic and mechanical diagnosis listed for your concern. Those are the major steps for diagnosing the AODE transmission. Now, let's review the order of these steps. First, carefully interpret the customer concern. Second, perform the preliminary checks. Third, verify the customer's concern. Fourth, check the diagnostic condition cause charts to see what routines must be performed. Fifth, perform the EEC4 quick tests with the Superstar 2 tester. Sixth, have any engine codes serviced. Seventh, perform pinpoint tests for the transmission codes you received. Eighth, perform the bench tests using the transmission tester if you're directed to perform electrical diagnosis. And finally, perform the transmission tester road tests if the bench tests failed to locate a problem. Now please stop the tape again and answer review question number 22 in your reference book. We'll show you the answer in a moment. For review question 22, you were asked to number the AODE diagnostic steps in the order which they are normally performed. The answers are as follows. Number 1 is the preliminary checks. Number 2 is verification of the customer concern. Number 3 is a check of the diagnostic condition cause charts. Number 4 is the quick tests. Number 5 is the pinpoint tests. Number 6 is the bench tests using the transmission tester. And number 7 is the road tests using the transmission tester. Now that you know the major steps, let's run through a typical AODE diagnosis sequence and take a look at these steps in action. The customer of this town car says that the vehicle accelerates fine up to about 25 miles per hour. Then it gets sluggish and the engine seems to whine. Your interpretation should tell you that this is a possible shift problem. We'll perform the preliminary checks first. After verifying that there is no non-factory add-on equipment, we'll perform the fluid level and condition check. The level looks good, and the color and smell appear to be normal. Next, we'll check the wiring harnesses for disconnected connectors or obvious damage. Everything looks good here, too. So we'll move on and perform a road test to verify the customer concern. In our case, the road test shows that the vehicle shifts from first to second normally, but does not shift to any higher gear. Your next step should be to look up this shift condition in the shop manual diagnostic condition cause charts. On the index for these charts, you'll find the category Some or All Shifts Missing. That looks like the one we want. On the chart for the condition, we see that the possible causes can be either electrical, hydraulic, or mechanical. Remember that you should always perform the electrical routines first. The chart says that the first course of action for our shift concern is to run the EEC4 self-test, or have an engine performance specialist run it. The self-test is covered by the quick tests in the Powertrain Control and Emissions Diagnosis Manual. With all safety steps observed, connect the Superstar 2 tester to the self-test connector. It's located in the engine compartment on the town car. The first quick test you'll need to run is the key-on engine off test. For this test, you must be sure that the engine and transmission are at normal operating temperature. With the engine turned off, set the tester mode switches to the fast code and EEC4 settings. Now turn the tester power on and wait for the 0 display. Next, latch the center button down and turn the key on without starting the engine. The tester will run the self-test. The key-on engine-off test will retrieve both hard fault codes and continuous test memory codes from the EEC4 processor. To view the codes after the self-test is complete, unlatch the center button. Then use the memory scroll arrows to check the codes. The first code you see here is a hard fault, code 622. The next code, number 10, is a separator code, which lets you know that the remaining codes are from continuous memory. So the next code you see here is the continuous code 111, which is a pass code. After recording these codes, we must now unlatch the Superstar 2 test button, then perform the engine running quick test. For the engine running test, start the vehicle and warm the engine to normal operating temperature again. Now turn the key off and wait 10 seconds. Next, you must go back to the Superstar 2, latch the center button down, then start the vehicle. You can now view the engine running codes by again unlatching the center button and scrolling using the memory arrows. The engine running test provides hard fault codes only. As you can see, we got only the code 622. If you do receive any additional codes, remember to write them down, because when you use the transmission tester later, some false codes will be set. Now, let's look up the code 622 in the 3-digit service code chart for passenger cars in the Powertrain Control and Emissions Diagnosis Manual. Once you find your code on the service code chart, you'll need to find the pinpoint test that goes along with it. According to the chart, you must begin at pinpoint test TC1 in the Powertrain Control and Emissions Diagnosis Manual. Pinpoint test TC asks you to perform a number of tests to determine if the cause of code 622 is in the processor or the wiring outside the transmission. If these checks fail to find the problem, you will be directed to the vehicle shop manual to see if the concern is inside the transmission. According to the pinpoint tests in the vehicle shop manual, code 622 is diagnosed in pinpoint test A. Pinpoint test step A1 lists several items that must be checked in order to proceed. Many of these items should have been taken care of during your preliminary checks or quick testing. After these have all been checked, move on to test step A2. Test step A2 asks you to make sure the vehicle harness connector is fully seated in the transmission connector and that the vehicle harness terminals are fully seated. If the connector and terminals are okay, you can move on to test step A3. Test step A3 asks you to disconnect the transmission connector and install the transmission tester number 007-00085. Since the connector is hard to see on the vehicle, we'll have to show you this operation on the bench. However, be sure to only remove the connector by depressing the tab and pulling up on the harness. Do not attempt to pry on the connector with a screwdriver. you'll damage the connector and possibly cause future transmission concerns. To install the transmission tester, you'll need to select the AODE pigtail harness and overlay from the tester kit. These items are dedicated exclusively to the AODE. Simply install the large connector of the pigtail to the transmission connector. For the AODE, you'll also need to disconnect the output shaft speed sensor connector and install the small tester pigtail connector to the sensor. The other end of the pigtail harness is installed into the tester itself. However, you may wish to install the universal extension cable from the kit between the pigtail and the tester. This will be especially helpful for routing the tester into the passenger compartment. Now, make sure the gear select switch is in the ohms check position, and then plug the tester power supply line into the vehicle's cigarette lighter. Now the tester is ready for use. When you first plug in the tester power supply, make sure all of the LEDs light up momentarily. This verifies proper tester operation. The first specific test in test step A3 says to perform the shift solenoid functional test, which verifies the electrical operation of the solenoids. To perform this test, simply select bench mode on the tester. Select the desired solenoid on the tester rotary switch and press the click test button. The click may or may not be audible, so be sure to check the related LED next to the solenoid jack. If it's green, the solenoid is okay. If it's red, there is a short to power somewhere in the circuit. If the LED stays off, there is no continuity in the circuit. Shift solenoid 1 appears to be okay. Let's try shift solenoid 2. There is no click at solenoid 2 and the LED is off, so a problem here is likely. According to test step A3, we must now go to test step A5. Test step A5 is a check of the solenoid resistance. To perform the resistance check, move the rotary switch to the ohms check position. Since we know there's a problem at solenoid 2, we'll check it first. Connect the negative lead of a digital volt ohm meter to the SS2 jack on the tester, and the positive lead to the solenoid 2 vehicle power or V-power jack. You can see that the resistance at shift solenoid 2 is infinite. Test step A5 says the resistance should be between 20 and 30 ohms, so we know there is an electrical problem with this solenoid or the internal transmission harness. This condition could either be caused by a loose, disconnected, or open wire at the solenoid, or by the wiring inside the solenoid itself. Pinpoint test steps A6 through A11 will help you determine if the transmission wiring or the solenoid is at fault. That's a typical AODE electronic diagnosis procedure. We emphasize that the major steps we gave you earlier are only a guideline. The actual steps you take will depend on your interpretation of the customer complaint and the results of each test. Now, please stop the tape here and answer the final 3 review questions in your reference book, numbers 23, 24, and 25. We'll show you the answers once more when you restart the tape. There are 3 correct answers to question 23, B, C, and D. On a transmission such as the AODE, the essential preliminary checks are the fluid level and condition check, the checks for loose or disconnected electrical connectors, and a check for non-factory add-on equipment. The drive cycle test is not a standard preliminary check and should only be performed when directed by the shop manual. The correct answer to review question 24 is B. Before using the transmission tester, it is important to first run an EEC4 self-test and record all codes received. Using the transmission tester will cause some false codes to be set. Finally, the correct answer to review question 25 is A. The solenoid functional test performed in the service bay verifies the electrical operation of the solenoids. Hydraulic operation of the solenoids can be verified on a road test using the transmission tester. This concludes part 2 of our presentation on the AODE transmission. We hope you've learned something about the basic diagnostic procedures for the AODE, especially those steps involving electrical diagnosis. For our first Tech Tip segment, we'll show you the proper throttle valve or TV pressure adjustment for the non-electronic AOD transmission. We'll perform the procedure on the AOD-equipped car. Then we'll show you the differences in the procedure for trucks. To perform the TV pressure adjustments, you'll need a 0 to 60 psi pressure gauge. The TV pressure gauge set T86L 70002A1 or equivalent is recommended. This type of gauge has better low-end accuracy than gauges with a higher pressure range. You'll also need the TV cable gauge block T86L 70332A or equivalent. To begin the TV pressure adjustment procedure, attach the 0 to 60 psi pressure gauge to the TV pressure port on the transmission and route the gauge outside the vehicle so you can easily see it. Next, remove all items necessary for easy access to the throttle lever. This will probably mean removing an air cleaner or inlet tube. Now insert the angled end of the TV gauge block between the plastic rod and the crimped slug on the end of the TV cable. Be sure to push in the gauge block as far as it will go. With the gauge block in place, you should now start the car and let the transmission warm to normal operating temperature. To ensure an accurate pressure reading, the fluid should be between 100 and 150 degrees Fahrenheit, warm but not too hot. Next, set the parking brake and place the shift lever in neutral. It's important to select neutral range when you make this check and not park. With the gauge block in place and the engine idling in neutral, TV pressure in the AOD should be about 30 to 40 psi, with a desired reading of 33 psi. Whatever the reading is, make a note of it. Now leave the engine idling in neutral and remove the gauge block tool. This will allow the TV cable to return to its original position. The pressure reading with the gauge block removed should be at or near zero. Record this reading too. If either of your pressure readings was out of range, check for damaged TV cable components and make any necessary repairs. Then adjust the cable as outlined in the vehicle shop manual. If the pressure reading with the gauge block installed was low, you can adjust the overall pressure higher, preferably to the 33 psi mark. But make sure this doesn't push the reading with the gauge block removed over 5 psi. If the higher pressure reading was within range, but the lower reading too high, you can adjust the TV cable to lower the overall pressure. However, make sure you don't go lower than 30 psi with the gauge block installed. When performing AOD throttle valve pressure adjustments on trucks, please note the following changes to the procedure we've just covered. To gain access to the TV cable end on some trucks, you'll also have to remove this protective cover. In addition, the gauge block tool for truck applications should be installed between the plastic fitting on the throttle lever and the slug at the end of the cable. The TV pressure specification with the gauge block installed is also slightly different for trucks. The acceptable range is 26 to 36 psi, with an ideal value of 29 psi. With the gauge block removed, as with car applications, the pressure reading should be less than 5 psi. If TV cable adjustments are necessary, check the proper truck shop manual for adjustment procedures. The Rotunda Transmission Tester number 007-00085 is a new diagnostic tool which has applications for the following automatic transmissions: the E4OD, the AXODE, the AODE, and the A4LD. The tester helps technicians quickly verify if selected electronically controlled automatic transmission concerns are located inside the transmission itself. It allows the technician to operate the transmission independently from the vehicle electronics during in-shop or road testing. In a sense, you are the processor for the transmission electronics. The transmission tester is also an essential part of the electrical pinpoint tests found in the vehicle shop manuals, starting with the 1992 publications. The components of the transmission tester kit include the tester unit, 4 tester overlays, one for each transmission application, 4 pigtail cables, again, one for each transmission, and 1 universal extension cable. The transmission tester has 2 modes of operation, bench mode and drive mode. The bench mode includes all checks that are normally made with the vehicle engine off. First of all, you can check for sufficient vehicle battery power using the exterior power jacks in the lower right corner of the tester. Simply install the appropriate volt-ohm meter leads into these jacks to see if the vehicle battery needs charging before you can use the tester. You can also perform selected solenoid functional tests on the tester by selecting the solenoid on the rotary dial and pressing the click test button. An LED lets you know the status of the solenoid and its circuit. You can also use the tester as a breakout box for checking voltage, continuity, and resistance. Just install volt-ohm meter leads into the tester jacks as directed by the tester instructions. For resistance checks, make sure the tester rotary switch is set to the ohms or ohms diode check position, or damage to your ohm meter may result. Another available bench check for the AODE, E4OD, and the A4LD is the solenoid diode test. This check involves installing a jumper between the diode test jack and the designated solenoid jack. When the diode test button is pressed, a green LED lets you know if the diode is okay. Those are the major bench mode functions. For tests with the engine running, either in the service bay or on the road, you'll need to select the drive mode. Major tester functions in the drive mode include manual selection of gear ranges, converter clutch functions, coast clutch functions, and TSS and OSS sensor functions for road testing. To initiate shifts into particular gear ranges, you will use the rotary gear select switch in the lower left corner of the tester. To enable converter clutch and other functions, you can use the activate buttons on the tester. Also, breakout box functions can be performed under selected engine running conditions in the drive mode. Those are the major functions of the transmission tester. Now let's take a look at these functions in detail as we discuss the diagnostic procedures using the tester. Before you use the tester, be sure to make all of the necessary preliminary checks as outlined in the shop manual. If the vehicle is drivable, perform a road test to verify the customer concern. Next, perform the EEC4 self-test as directed by the Powertrain Control and Emissions Diagnosis Manual and record all codes retrieved. This step is extremely important. When you install the transmission tester, you will disconnect the transmission connector, causing some false codes to be set. If there are any non-transmission codes retrieved, have these serviced first. Now you're ready to use the tester. First of all, you must select the correct overlay from the tester kit and place it on the tester unit. Next, you'll need to disconnect the vehicle harness connector at the transmission after removing any heat shields for access. Since the connector is hard to see on the vehicle, we'll show you this operation on the bench. However, be sure to only remove the connector by depressing the tab and pulling up on the harness. For the AODE, you can simply pull up on the connector. Do not attempt to pry on the connector with a screwdriver. You'll damage the connector and possibly cause future transmission concerns. To install the transmission tester, you'll need to select the appropriate pigtail harness from the tester kit. Notice that each tester pigtail harness has a different transmission connector, and the AODE pigtail has 2 large connectors. Simply install the large connector of the pigtail to the transmission connector. For the AODE and AODE, you'll also need to disconnect the output shaft speed sensor or turbine speed sensor connector and install the small pigtail connector to the sensor. The other end of the pigtail harness is installed into the tester itself. However, you may wish to install the universal extension cable from the kit between the pigtail and the tester. This will be especially helpful for routing the tester into the passenger compartment. You'll also need to hook up a 0 to 300 psi pressure gauge to the transmission line pressure tap. Now make sure the tester rotary switch is in the ohms diode check position. The last connection to make is to plug the tester power supply line into the vehicle's cigarette lighter. As soon as you do this, the tester's LED should light up momentarily to verify that the tester is working properly. Pay careful attention to the LED in the top ID band. This LED will light up to indicate that you've selected the correct overlay for the pigtail that's installed. Now the tester is ready to go, so let's look at some specific tests you can perform. We'll start with the bench mode. Bench mode tests are generally run before any road tests to verify proper electrical operation of the transmission. To begin, you must make sure the tester mode switch is in the bench position. Let's look at the resistance checks first. There are several resistance checks you can perform in the bench mode. To check any resistance, you must first make sure that the tester rotary switch is in the ohms diode check position to avoid damaging your ohm meter. To check EPC solenoid resistance, you must connect the negative ohm meter lead to the EPC jack on the tester and the positive lead to the corresponding V-power jack on the tester. Check your resistance readings against those in the tester instructions or in the shop manual pinpoint tests. To check resistance at a converter clutch solenoid, any shift solenoid, or the E4OD coast clutch solenoid, again connect the positive ohm meter lead to the V-power jack and the negative lead to the corresponding solenoid jack. Again, check your readings with those in the tester instructions or shop manual. In addition to solenoids, you can measure resistances at any of the transmission sensors shown on the bottom of the overlay. For these checks, simply connect positive to positive and negative to negative for the sensor you're checking. To check for a sensor short to ground, you will use the engine ground or negative battery jack on the tester for your negative ohm meter lead, and then connect the positive ohm meter lead to any positive sensor jack. There should be infinite resistance for all of these checks. You can check solenoid voltages by selecting the 20 volts DC scale on the volt ohm meter and move the rotary switch to a solenoid position. Then connect the negative lead to the negative solenoid jack and the positive lead to the V-power jack. When you press any of the solenoid activate buttons, the voltage should change. The LED will be green if the solenoid is electrically okay. Another simple bench test is the solenoid functional test, also called a click test. To perform this test on the shift solenoids, set the rotary dial to the desired solenoid, then press the click test button. A click should be heard, but shop conditions may make hearing the click difficult. So be sure to also observe the LED for the solenoid you're testing. If the LED is green, the solenoid and circuit are okay. If the LED is red, there is a short to power in the solenoid circuit. And if the LED is off, there is no continuity or a short to ground in the solenoid or its circuit. You can also perform the functional test on the EPC and converter clutch solenoids by pressing the activate button for each. However, the modulated converter clutch solenoids on the AODE and AXODE may not have an audible click. If this is the case, you can still functionally test the solenoid by looking at the LED. The LED should again be green to indicate normal solenoid operation. You can also check for a short to power or other electrical problem using these LEDs. A red LED indicates a short to power, while an LED that stays off indicates no continuity or a short to ground. The final bench check is the solenoid diode test. This test is performed on current E4OD, AXODE, and A4LD equipped vehicles. To perform the diode test, connect a jumper wire between the diode test jack and any solenoid jack labeled with a diode symbol and check mark. When you press the diode test button, the diode LED should light green. If the LED does not light, the solenoid internal diode is bad and the entire solenoid or solenoid assembly must be replaced. Now, let's move on to the engine running or road tests. For these tests, you'll need to select drive mode on the tester and move the rotary gear select switch to the first gear or 1 position. Be sure to take all the necessary safety precautions before you begin your drive mode tests in the shop. One such test is the EPC solenoid operation check. To begin this test, start the vehicle and observe the line pressure. Since there is no EC4 input to the EPC solenoid, line pressure should be at its maximum. With the gear select switch in the 1 position, press the EPC activate button and observe the pressure drop. Line pressure should now drop to the minimum idle value. If the pressure doesn't drop, refer to the appropriate shop manual for EPC solenoid diagnosis. If the pressure never reached maximum, refer to the shop manual for low line pressure diagnosis. One special note on EPC testing. Do not hold the EPC test button down and attempt to stall the transmission. Transmission mechanical damage will result. With the engine running and the vehicle in the shop, you can also perform an engagement check. For this check, set the rotary gear select switch to the 1 or first gear position. Then depress the EPC solenoid activate button until line pressure drops to idle value. While holding the button down, move the shift lever from park to reverse, then from reverse to drive. The vehicle should shift into each range with minimal engagement feel. Now release the EPC button and repeat the shift lever movements. The engagement should now be more firm. Another drive mode test you can perform, either in the shop or on the road, is the output shaft speed or turbine speed sensor functional check for the AODE or AXODE. With the drive wheels raised off the floor, monitor the speed sensor voltage using a DVOM. The DVOM should be set to the 20 volts AC scale and installed into the sensor jacks. If the sensor is functioning properly, voltage should increase as vehicle speed increases. The remaining drive mode tests are performed on the road. The first is the upshift and downshift test. We'll show you the upshift and downshift tests for the E4OD, AODE, and AXODE transmissions first. The test for the A4LD is somewhat different because only the 3-4 and 4-3 shifts are electronically controlled. With the tester mode switch in drive position, place the rotary gear select switch in the first gear or 1 position. Now place the shift selector in the overdrive range and accelerate the vehicle. When vehicle speed reaches 15 miles per hour, turn the rotary gear select switch to second gear and make the following observations. Does the vehicle upshift? Don't worry if the shift seems firm. All shifts will be firm because the tester keeps the EPC solenoid at maximum pressure output when a gear range higher than 1 is selected. Do the appropriate solenoids activate or deactivate as indicated by the proper LEDs being on or off? Refer to the solenoid on-off chart next to the shift solenoid's LEDs to make this verification. At 25 miles per hour, move the rotary gear select switch to 3 and make the same observations. At 35 to 45 miles per hour, move the rotary gear select switch to 4 and do the same. After 4th gear is reached, reverse the order of the steps and observe the downshifts. For the upshift and downshift test on the A4LD transmission only, you must place the shifter in the overdrive range and select the 3rd gear or 3 position to start. Then accelerate to about 40 miles per hour, allowing the transmission to hydraulically shift through 1st, 2nd, and 3rd gears. At about 45 to 55 miles per hour, turn the gear select switch to the 4 position and make your observations. Then turn the switch back to the 3 position to check the downshift. For converter clutch engagement checks on all transmissions, accelerate the vehicle through 1st, 2nd, and 3rd gear checks as you did for the upshift test. For the E4OD, AXODE, or AODE, you can accelerate to 35 to 45 miles per hour. For the A4LD, you should accelerate to about 50 miles per hour. While in 3rd gear, depress and hold the converter clutch activate button and observe the following. Does the converter clutch engage? Does engine RPM drop? Does the converter clutch solenoid LED light up with a green color? Record your observations as before. On E4OD equipped vehicles only, there is also a road test for the coast clutch solenoid. To check coast clutch engagement, simply use the rotary gear select switch to accelerate through first, second, and third gears as you did for the upshift test. While in third gear, depress the CCS activate switch and immediately back off the throttle. Then make the following observations. Does the coast clutch engage? Does engine braking occur? Does the coast clutch solenoid activate, as indicated by a green LED? Remember to record your observations. Those are all of the tests you can perform on the transmission tester. Of course, you will perform only those tests called out in the pinpoint tests or those necessary to diagnose your particular transmission concern. When you're through using the tester, there are a few final steps to observe. First of all, remove the tester harness from the transmission connector by depressing the tab and lifting up. On the AODE, simply pull up on the connector. Do not use a screwdriver to separate the connectors or you'll damage them. Next, install the vehicle harness connector to the transmission connector. Verify that the connection is secure by pulling up on the vehicle harness connector. Next, remove the tester power supply from the cigarette lighter. Now you must clear the codes from the EEC4 processor. The recommended way to do this is to initiate a self-test on the Superstar 2 tester. Turn the ignition key on, then unlatch the tester button before the self-test is complete. Exact instructions for clearing codes are in the Powertrain Control and Emissions Diagnosis Manual. Next, rerun the EEC4 self-test to verify that there is only a passcode 11 or 111. Finally, drive the vehicle one more time to verify that the customer concern has been eliminated. That wraps up this presentation of the automatic transmission tester. Be sure to consult the tester instructions booklet for complete details of all the procedures we've shown you and for specifications on various tests. And be sure to review this videotape as needed to master the use of the transmission tester.